All right, hello people watching this video. We are doing the front half of Chapter 8 review today. We are also going to add some formulas to this paper, and this is the paper that you get to use with your test, okay? We're gonna test over this chapter on probably Friday. I was gonna do like a whiteboard day maybe, but I think I would rather have us do the stats project Monday, Tuesday of next week, okay? So we have a stats project. We have to gather some data from around the school. So that's going to be kind of crazy. But, so we're going to test it over this chapter on Friday. Here we go. Front half of the review. All right, here's what I want you to do really quickly. You do number 1, number 2, number 3 by yourself. Go right now. I'll check.
Pass. Just pass.
Do number 1, number 2, number 3. It's either going to be a survey, experiment, or observational study. I will tell you there is one of each. So figure out 1, 2, and 3. Which one is a survey, an experiment, or observational study? They're kind of hard. Some of them are like, I don't know. It could go one way or the other.
Research group.
So, survey, experiment, observational study. Do 1, 2, 3. Go.
That's number 1 observation.
Put what you think. I don't know. Put what you think. Put what you think. Put what you think.
US one is
What?
Yeah, you're screwed.
Oh, did I have it? I gave you 2 of them? Oh, yes, I did give you one yesterday. You know, yeah, I suppose I better
No,
figure
that's a
that.
survey. No, number 3 is a survey. No, wait. A nutrition research group wants to determine the medicates.
I'm not at all confident on what I just wrote down.
Yeah.
That's what
I know one of them I'm like, yes, I know for sure it's that one, right? But the other
Number
2,
3
it's
is
like,
definitely a survey.
oh.
So could 2 be an observational since they look at what their grade is?
Yeah. All right, so which one is like for sure has to be this one, probably?
Number 3 is a survey.
Number 3 is a survey. How do you know that? They're asking, right? They're asking the question. It is a survey. Now we have to decide. Okay, let's go back to number 1. A research group wants to determine if playing music in a patient's waiting room reduces stress level.
Observational study.
Experiment. Because
Okay.
you have one room.
So I get that you would have to observe their stress level, right? Like that's part of it. But if we're talking about reducing stress level, I won't know if it reduces unless I do one room that has no music and one room that has yes music, right? And I have to provide the music, and I'm doing something to 2 groups, and that's going to be more of an experiment. So that's why I would lean more toward experiment for the first one. I get that you're doing some observation in your experiment, but you would need 2 groups in order to determine reducing stress level, okay? Number 2, a nutrition research group wants to determine whether 9th grade students were reported having eaten breakfast. I am not providing the breakfast to them.
Observational.
This is where I'm just observing their grades based on who ate breakfast and who didn't. I'm just collecting the data. I am not doing anything more than just collecting data. There are kind of 2 groups, but I did not have to split them into the 2 groups. They are naturally occurring 2 groups, and that is just an observational study. Do you see the difference between the 2? That's how I would categorize them. I get that there's a little bit of a gray area there, but that's how I would do it anyway. Okay? All right, number 4, we have favorite colors. So this graph goes with number 4, and we are talking about 2,000 students at this elementary school. We did not survey all 2,000 students. Let's figure out how many we did survey. How many people said red? 6. And blue is 12, and green is 8, and pink is also 8. And if we add those all together, how many people did we survey? 34 if you add them, right? Now, when you go to add things together, do you add them in order, or do you add them like based on which ones come out nicely? Because like if I see these numbers, I'm inclined to add those 2 first, right? Like, is that what you do? Okay, that's a good strategy to do because you'll get to the total faster, right? 8 and 12 is going to make a nice even 20 number, right? Rather than adding them in order. Okay, so that's what I would do. 34 is the total. So we did not survey all 2,000. We only surveyed 34. All right. Based on the results in the graph, what is the most reasonable inference about the number of students who chose pink as their favorite color? All right. So let's talk about pink.
They have horrible color taste.
Right.
Remington.
How many people?
Do you not see
How
the
many
cancer?
people?
Okay.
What did you say?
Okay.
Oh, boy.
Cancer awareness, not cancer.
All right.
Get what I'm
Do not.
What
stand
percent?
with
How do we figure out what percent said pink? 8 divided by 34, right? 8 over 34 said pink, which as a percentage is how many percent? Somebody have a calculator. 8 divided by, Brian's got it. He's on top of it. 8 over 34 is 0.23, 0.23, or 23% said pink, which, if there's 4 categories, is actually less than a fourth, right? So, like, there's more in some of the other categories. Okay, just a thought. But they want, based on the results in the graph, what is the most reasonable inference about the number of students who chose pink? So if I'm talking about out of the 2,000, how many would have chosen pink out of the 2,000? How do I find that? 2,000, and I'm going to take it times 0.23 as a decimal, right? So 23% of 2,000 or 0.23 is, can you do this in your head? Hold on, don't give me the answer. Can you do this in your head? You're really taking 23 times 2, right? What's 23 times 2? 46, but how many zeros? Is it 46? Is it 4.6? Is it 460? Is it 4,600? Which one is it? What? 1 0. 460, right? 460 would be about a quarter of the 2,000, right? You can do that stuff in your head, right? You're just multiplying by 2, but then adding some zeros. So 460 students would have said, probably around 460, would have said pink was their favorite color, right? Probably not 460 exactly, but roughly based upon our sample, okay? All right, now I'm interested to see how you do this next problem because we did it like 3 different ways last period. Random sample of 20% of the teachers in a district were chosen, found that 40% were female, but we only surveyed 20% of them. If we surveyed all of them, how many would have been female out of the whole district? How do you do this thing? That's what somebody said last period. So they're saying that 20% is equivalent to 40 females, right? 40 females is equivalent to 20%. But if we were to have surveyed all 100%, I would have to multiply this by 5, right, to get 100% over here. So I'd have to multiply this by 5 to get 200, right? Do you see how that works out? Okay. 25 is to 40 as 100%, or excuse me, 20 is to 40 as 100% is to 200, right? Okay, a couple other ways that you could have done that. We could have said the whole number, we're taking times 20% or times 0.2. That's equivalent to 40. So 40% is 40 is 20% of a number, right? And then to solve for x, you would divide by 0.2. And 40 divided by 0.2 is, of course, 200 also. So you could have solved it that way. Or kind of along the same lines as the first one, 40 over out of how many is 20% out of 100%, right? And then you could cross multiply and divide if you like to do it that way. So whichever way makes sense to you, you're going to get 200 no matter what. All of those will give you the right answer as long as you set them up correctly. Got it? Okay. All right. Next, we have the difference between the theoretical probability and experimental probability. All right. What's the difference? Like, what is theoretical probability? Like what should happen or what has happened in the past according to past data. And then the experimental probability is kind of like the current or like when I'm conducting it right now, what are my results that I'm getting, okay? So let's see, for a particular baseball player, out of the total number of times he reached the base, he gets a walk 6% of the time, a single 55%, a double is 30%, a triple is 1%, and a home run is 8%. Is that theoretical or is that experimental? In theory, in the past, that's what has happened. Now, this is what has happened now, right? That's the results now. So I'm going to compare those numbers. Do you guys know what they mean by like a walk and a single and a double and a triple, right? Like a walk is like a walk. You're walking to the first base, whatever, because you got hit with the ball or whatever. Anyway, or you got walked because the pitches were crappy. That is happening 6% of the time. That's what they tell me in the paragraph. So put that off to the side. This is the theoretical 6% of the time. A single means you make it to first base, but you hit the ball. It wasn't that you got walked. Single made it to first base. That was 55% of the time. A double means you make it to second base. That's 30% of the time is that happening. A triple is 1% of the time. And a home run was 8% of the time. According to past data or in theory what has happened before, right? What's missing on here? I looked at this and I'm like, does this person never strike out? right? Like, that's what I'm thinking. But then, I said that last period, I'm like, that's not a category on here. But Matthew Hafer was like, maybe they're just counting, like, the times that he made it on base or scored or whatever. Like, he's not, they're disregarding. What?
It almost says that in the paragraph.
Does it say that in the paragraph?
Maybe he's
Out
just
of the
good.
total number of times he reaches base. Okay, so they're X-naying the number of times he strikes out, I guess, or something. I don't know. Anyway, all right. So let's talk about experimental probability now. Okay, experimental probability. The total number of times I made it on base was how many? How many is total number of times I made it on base?
100.
100, which makes calculations really easy. 5 times I got a walk, which 5 out of 100 is?
Attempted murder.
5%. What percent single? 60. What percent double? 25. I got no triples this year or whatever period we're talking about. And then 10% home run. So I am getting more home runs, but I'm getting less triples, etc. Right? Like that's how these are breaking down. They want us to compare them by using a bar graph. So I'm going to put my bar graph here. That's why I gave you lots of room. And here's my bar graph. Okay? We have some categories going across the bottom, and they are walk, which I'm just going to say is W. We have a single, a double, a triple, and a home run. Those are my categories. Okay? What is that axis title, though? Like, those are my labels, but what's my title going to be? What do they call it? Outcome. I like that. Outcome. Okay, what goes on the side there?
Frequency.
The frequency. We're going to put them as percentages, so frequency. Okay, and what's the highest frequency that we have to go to?
100.
Out of either one.
50, 60.
60, right? I don't need to go necessarily all the way to 100. I'm just going to go 60%. Okay? And since 60% is like a nice even number, I'm just going to like eyeball and split this in half, right? And that should be at 30. And then I need like 2 more slots, right? So try to like separate him into thirds, right? So 10%, 20%, 30%, 40, and 50. And then 60 is my top. Okay? So, I mean, try to like make sure your spacing is nice and good. And we're going to do a double bar graph. Okay? These bars are not going to touch. This is not a histogram like we've done before, right? These bars don't touch because like walk and single and double and triple, those are categories. Those don't touch each other. But the walk, we're going to have 2 columns. I'm going to do my theoretical probability in blue. So in the past, my walks have been about 6%. So I'm going to do that for my little tower. And then what are they now? 5%. So I'm going to do a little bit lower. And then you can see that like that bar has changed a little bit. It's gone down like slightly. Okay. My singles before were 55. So I'm going to mark at 55. And there's my tower. And now it's at 60%. So something of this nature. Okay. So make your towers look something like that. Okay. Doubles was before 30%. So I'm going to mark them at 30-ish. And now it's at 25%. So a little bit lower than that. About there. That's my double. So you can see how those things have changed from first time theoretical to experimental. Triple, though, has gone from 1 to 0%. So I'm just going to do a little 1 right here and then not have a 1 for the second one. And then home run is 8%. Ooh, it's very hard to eyeball. And we went up to 10%. So ish there. Something of that nature. Okay, those are your bars. And then you can kind of do some comparisons. Now this bar graph also tells me which categories were the most prevalent or like what's going to happen most of the time. A single. Okay, and then double comes next, right? So I'm usually probably going to get a single or double the majority of the time, right? I'm very, very rarely do I get a triple. Do you think that's true? If you get a triple, you might as well get a home run, right? Like,
Not
usually,
really, 'cause that's
I
the basis
mean,
you're not for,
you know.
But outfielders have to have a really bad like set to get a triple.
Yeah. But usually, like, if you get to
second.
if you get to third base, you might as well make it home, you know, like, I don't know.
So I'm saying if you don't make
I
it
know.
up.
Maybe if you're on second.
Don't even.
Yeah, you're on second.
There's a lot of stealing for third, usually, right? or like
First
first to second. There's a lot of stealing in
That's
this.
the most.
Maybe. Yeah. Okay. I guess. Sure. All right.
Mouse impersonation.
Next, last one, kind of, right? Are we stopping after this one? 8-3. Here we go. This is a weighted average. Here we go. Weighted average. The number of students and then the grades per semester. Okay. Number of students, grades per semester. Here we go.
Just plastic.
So we had 2 students. You gotta listen. We're on the last one. 2 students get 100%. 8 students got a 90%. 6 students got an 85. 2 got a 78, and 3 got a 65. Okay, so this is how this breaks down. The highest 2 categories are my 8 and 6. So if I were to guess what the average would be, it would probably be between 85 and 90. Do you see how I would be led to believe that? Maybe closer to 85 because then there's these people that are pulling it down also, right? So like maybe around this range or like slightly above that-ish, maybe, is what my average is going to be. How do I find the average? Like for the whole class.
I'm not 100% blonde.
How do I do this?
Like, what? One of my friends, like one of my
What?
guys in my class.
Just guesstimate
he's so
87
blonde, he
and
doesn't
call
have
it a day?
eyebrows. Like,
Sure.
eyebrows are so blonde,
What do you do? Yeah, so like I hear what Jack's saying over there. He says 2 students got 100. So that's like saying 100 plus 100 plus 90 plus 90 plus 90. And there's 8 of those, right? And we keep adding them all together, right?
Multiply over, then you add them.
Or let's just multiply them together, right? And figure out those, okay? What's 100 times 2? 200. Okay, you got to get a calculator out for some of these other ones. Can you do 8 times 90?
Yeah.
You should be able to.
720.
720, right? 72 is 8 times 9. Okay, 85 times 6, I don't know what that is. 480 plus 30, so 510. Yeah. 78 plus or times 2 is 140 plus 16, so 156. Look at that, we're faster than a calculator. 65 times 3 is 180 plus 15, 195. True? Yes? All right, add them all up. I can't do that in my head, sorry. I'm not going to try.
5, 11, 13, 21.
I know my limit. I know when I can work faster than a calculator, and I know when I can't. What?
Oh yeah, 1781.
1781? Okay, now, you get to this point. You know what to do from here, or like up until this point. Now what do we do? What do we divide by?
21 because there's 21.
Okay, we're trying to find the average grade, right? So I'm going to divide the students off, right? There's 21 students. So I'm going to divide by 21, and that gives me a grade of,
84.8.
ooh, 84.8. That is not where I thought it was going to be. I thought it was going to be between these two numbers, but 84 is like slightly lower than that. Probably because these people are pulling it down, right? And 65 is kind of an outlier. The rest of them are pretty close together, but 65 is like a really low score, okay? So 84.8 is the average. There we go. All right, last question is number 8, which got cut off. That is another question. Last thing, it says population proportion. Find the population proportion of students who earned a grade less than 70. Who earned a grade less than 70? 3 people. Okay, how do I write that as a proportion?
3 out of
3 out of
21.
21, which is
So small.
0.14.
1/7 or 0.14 or 14%, and I don't care how you write it. All of those things are technically proportions, right? It doesn't matter whether it's a fraction, decimal, or percent, because they're all equivalent, okay? All right, last thing. Before we put away, I'm going to have you write some formulas down. At the top of the next page, which is what we're going to start on tomorrow, is margin of error and calculating sample size, okay? So you guys have this bell curve sheet here, empirical rule, right? Okay, I want to know how to calculate margin of error. So typically, like in the past, we would say like 20% of all people like chocolate ice cream or something, right? But that's not going to be true for the whole population. We would rather say like somewhere between like 15 and 25%, right? Okay, and my margin of error would be like that. Okay, so don't write this down. If we say 20% of people like chocolate ice cream, but let's say my margin of error is 4%. Don't write this down. Who actually likes chocolate ice cream?
Nice.
Somewhere between
16 and
16 and 24%. Does that make sense? That's what the margin of error does for you. So if I surveyed the sample told me 20%. But if I would do the whole population and get data from there, it would be somewhere actually between 16 and 24, right? Like that's what the margin of error does. Okay, so how do you calculate margin of error? 1 over
the square root
of n, and then you take it times 100 to convert it to percentage, okay? Now what does n mean?
the number.
The number in your sample. Okay, so the more people I survey or the more people I sample, what happens to the error? It goes down. The more work I do, right? I have to gather data from a lot of people if I want to have good data, which means less error, right? So they go like this direction, right? More people, less error, right? Okay, they're inversely related. That's exactly right, right? Okay, now let's say I'm trying to solve for n. Okay, so I say I only want a 2% error. Like if I want a 2% error, how many people would I have to survey? Now I work the formula backwards, and it is 1 over e squared. 1 divided by e squared will give me that. And maybe make a little note that e has to be a decimal, not a percentage. So before you put the e into the formula, if they say 2%, you want to write it as 0.02 to plug the e in. Does that make sense? Okay. So that's what you want for your error stuff. Got it? Good, good? And that will tell you how many people you have to survey in order to have an error of whatever, right? Okay, so those things are going to be some things that you need for your test. You get to use this paper on your test, so don't lose him. We're going to do the backside tomorrow and call it a day early, right?
Mm-hmm.
Yeah, we don't quit early very often, but there you go.
Look at this.